Now, for merge sort, okay, the key word here is merge. So we're going to try to do a series of merges. So we are going to start with an example, right? Because the example is going to clarify how we attempt to achieve this. Now, we say earlier that we have a problem of a certain size n. So let's imagine that you're given an array. The array is not yet sorted. It has size n. In this case, size 8. So the problem is to deal with an array of size 8. But we don't want to deal with the problem as a problem of size 8. We're going to pretend they are smaller problems. So we're going to pretend that instead of one array of size 8, we actually have 8 arrays of size 1. So these are essentially, individually, they are smaller arrays. Now if I have 8 arrays of size 1, each array is already sorted. Because any array of size 1 is already sorted, right? So then now I can start thinking in terms of, can I now make up another array that is also sorted but just slightly larger? And the way to do that is that we can go from 1 to 2. So how do we go from 1 to 2? We are going to take pairs of arrays of size 1 and then we're going to combine them. We're going to merge them. So think of it like a tournament, right? So imagine that there is a tournament going on. So we are going to pair them up and we ask them to play a match and see who wins, right? So you can imagine like, any kind of badminton or something. So you have 8 players and then you ask them to match up and play a game and see who wins. Now in this case, playing a game means that we're going to compare the number and see which one is smaller. So then once they compare 31 to 41, so 31 goes up, 41 goes second, right? But now we have an array of size 2 that is also sorted by combining 2 arrays of size 1. So we do the same here. 15 and 93, 15 is smaller, 93 goes up as well. 32, 40, 32 goes first, 40 goes second. 9 and 70, 9 is smaller, so 9 goes up and then 70. Now to achieve this, how many comparisons do we need? So every match is one comparison, right? So 1, 2, 3, 4, we're going to get to 4 arrays of size 2. So just now we have 8 arrays of size 1, we merge them, we get 4 arrays of size 2. So what is the next logical step? Now we are going to merge arrays of size 2 to arrays of size 4. Okay? Now, let's take a look at this now. So we're going to combine this one and this one into one array of size 4. So how do we get this? So we are going to exploit the knowledge that the arrays of size 2, they are individually sorted. So this is sorted, 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 sorted. So to combine two sorted arrays into a bigger array, we just need to look up the numbers that is the smallest in each array. So, and this is the leftmost number. So we're going to compare the leftmost here. So 15 against 31. 15 is smaller. So then 15 can go up first, right? And then 15 has left. So in this row, there is only 93. Because imagine that 15 has gone up first. So we're going to compare 31 to 93. So 31 is smaller, so then 31 goes up. Now leaving 41 and 93 behind, then we compare 41 and 93. 41 goes up and then 93 follows. Alright? Now we can do the same here. So we're going to compare the one that is leftmost first. 9 to 32. 9 is smaller, so 9 goes up. 32 and 17. 32 is smaller, so 32 goes up. And then 40 and 70. 40 is smaller, 40 goes up. Then 70 has nobody to fight with, 70 will go up. Okay, now, how many comparisons do we need to do in order to go from size 2 to size 4? So to make up an array of size 4, we will need 3 comparisons, right? Because every number that goes up, they go up because they win a match, right? Because it means every number that goes up require one comparison, except the last one. Because the last one has nobody to play a game with, they will just go up. So which means that we require 3 comparisons. So where are the 3? 15 to 31, 1. 31 to 93, 2. 41 to 93, 3. By then, 15, 31, 21 are already here. 93 doesn't have any comparison, it will just go up. So you're going to have 3 here, you're going to have 3 here. Now the final step is that we're going to go from size 4 to size 8. Right, so then we are just going to do the same process all over again. So 9 to 15, 9 goes up, 15 to 32, 15 goes up, 31 to 32, 31 goes up, 32, 41, 32 goes up, 40, 41, 40 goes up, 41 to 70, 41 goes up, 70 to 93, 70 goes up, and finally 93. So how many comparisons do we need to merge two array of size 4 into one array of size 8? In the worst case, we need up to 7. Because every number that goes up requires one comparison, except the last one, it doesn't require one. Alright? Now, so the idea of Mergesort is that we are going to try to split our problem into smaller problems. We don't want to deal with an array that is of size n immediately. So instead, we are going to pretend first, oh, I'm just dealing with size 1 array. Oh, look, it's already sorted. So then we're going to see whether we can make it a little bit bigger. So size 1, we go to size 2. Size 2, we go to size 4. Size 4, we go to size 8. Right? Now, let's talk a little bit about the complexity. Now, it's difficult to talk about the complexity unless we talk about the real numbers, right? But I'm going to just give you an idea of how this is done. So let's look at this. What are the two main operations that we are doing here? So one is that we are going to have a series of merges, right? So we go from size 1 to size 2. We go from size 2 to size 4. We go from size 4 to size 8. So now if you think of this in terms of level of merges, how many merge levels do we have? So we're going to have 1 here, 2 here, 3 here, right? If it is size 16, how many levels are we going to have? 4. So now 1, 2, 4, 8, this is similar to binary search, right? We just talk about the number of levels, it's going to be log n. Now log n is just a number of levels. Now but in each level, we need to do a number of comparisons, right? And if you look at the top one, to get the top one, we need to get n minus 1, right? So in that case, in the worst case, if you think about this in the worst case, is that you're going to have log n levels, and in each level, you're going to have up to n minus 1 comparisons. So generally speaking, it's going to be n log n. Okay, but if you want to analyze it deeper, you need to count exactly how many are going to happen in each level. Right? You will still come up to an expression that is going to be simplified to n log n. Now, n log n essentially is a lower bound for sorting algorithms. I mean, without any other special data structures, essentially you're going to get n log n. Now, the way that Mergesort works is that it's going to try to split the array into smaller size array. And then it's going to decide how to split based on its position. Right? So we are going, so for example, in this case, you have size 8. You're basically trying to divide this into two arrays that are size 4. Then size 4 becomes size 2, size 2 becomes size 1. Now, the other algorithm, that is quicksort, is going to do something similar, but it's going to try to divide the array, not based on position. It's going to try to divide the array based on value. So it's going to pick one reference value, which we call a pivot. And then we're going to split the array into two based on whether you're smaller than the pivot or larger than the pivot. And then you're going to split it into two. But the rest of the algorithm works in a very similar way. Right? But we're not going to look at quicksort itself. In class, I'm just mentioning it because you might be interested to see how it works. Now, so Mergesort works like this. Now, there is a set of algorithms that you need to understand, right? It's going to, I'm just going to mention a high level structure. Okay, this will take you a little bit of time to go in depth into it to see how it works. The first structure essentially is the merging. So this is the step where you're going to merge again and again. So that's why you go from size 1 to size 2, size 2 to size 4, size 4 to size 8. So this is the merging part. And then this is the part where you are identifying which pairs am I going to be merging. So remember just now we take any pair, the first two, second two, the third two, and so on. This is the one that is trying to take two groups and try to merge them. So it's going to call something else that is called merging. So merging is the one that actually does the comparison. So if you're going to count the comparisons, it's the number of times that you call on the less method. Now, the code looks intimidating, right? I think first, I want to make sure that you actually understand the steps correctly. So I think it's better that we do some in-class exercises in terms of the hands-on. When you go home, try to understand the code better. All right? So now, for the next 10 minutes or so, let's try to do something similar as the one that we did for insertion sort. But now we're going to do it for merge sort. Now, some of you may ask, how do we do this if the array is not a power of 2? So it doesn't neatly fall into 1, 2, 4, 8. So now, you just need to think of this in terms of a tournament. So you have 3 groups, for example. If the first 2 groups match up and then they fight, right? And the third group has nobody to go with, then you just advance to the next round. Then you're just going to play at the next level. So then after that, you're going to be merging 4 and 2. Right? So it's going to work something similar to that. Alright, so let's take the next 10 minutes to work on these exercises, then we will discuss them.